Hello everyone, welcome to my video. In this video, we are going to see about electrostatic capacitance. The word capacitance, it means the ability or the capacity of a substance to store something, of a substance to store. So, electrostatic capacitance means it refers to the ability or the capacity of a substance to store electric charges or electric field. It is denoted by the letter C. So we know about the equation for potential V is equal to Q by 4 pi epsilon 0 R. From this equation, as you increase the number of charges, the potential also increases. So the charge is directly proportional to electrostatic potential. So from this we come to a conclusion that Q is equal to C into V. This constant is called capacitance. So from this, rearranging this equation, you get C is equal to Q by V. So from this equation, you get an alternative definition for capacitance. We can define capacitance as the amount of charge required to increase the potential of a substance by unity. Required to increase the potential by unity. Unity means 1 volt by 1 volt. So that is the definition that you get from this equation. So for now, let us try to calculate the capacitance of a conductor. Capacitance of a conductor. So assume a spherical conductor whose radius is R. Whose radius is R. So from the equation, C is equal to Q by V. So in order to calculate the capacitance, first we should write the formula for potential. V is equal to 1 by 4 pi epsilon 0 Q by R. So substituting this, you get C is equal to Q by 1 by 4 pi epsilon 0 Q by R. So here the charges get cancelled and you get the equation as 4 pi epsilon 0 R. So this equation represents the capacitance of a spherical conductor. So this equation represents the capacitance of a spherical conductor. So next we can see a parallel plate capacitor. So what you're seeing on the screen is called a parallel plate capacitor. A parallel plate capacitor is nothing but two conductors separated by an insulator. In this case, the insulator is air or vacuum. So here in the diagram, they have not mentioned the medium the plates are there. So we should assume that the medium is vacuum. Okay. So now generally we denote capacitor by this symbol. So here as you can observe, one of the metallic plates is positively charged. So its charge density can be denoted as sigma plus, and the other metallic plate is charged negative, so it is represented by sigma minus. So this is the charge distribution of the plates. So by using Gauss law, we can calculate the electric field at the center. Electric field at the center due to the positively charged plate and the negatively charged plate. So we'll get equation such that E is equal to sigma by epsilon 0, where sigma is the surface charge distribution. So sigma is equal to Q by A. E is equal to Q by epsilon 0 A. So now assume that these plates are separated by a distance d. They are separated by a distance d, so that we have the relation between electric field and electrostatic potential. V is equal to E dot d. Now substitute the value of E from this equation. Q by epsilon 0 A dot d. So this is the equation for electrostatic potential at the center of two charged plates. So coming back to the equation for capacitance, C is equal to Q by V. So Q by epsilon 0 A dot d. So here also the charges get cancelled. You get the equation for capacitance as C is equal to epsilon 0 A by d. So this equation is the equation for capacitance of a parallel plate capacitor. So this is the equation of capacitance of a parallel plate capacitor. So next we are going to see the energy or the potential energy stored in a capacitor. Potential energy stored in a capacitor. So in this diagram, as we already know, so this plate is positively charged and this plate is negatively charged. Let the total charge in the positively charged plate be plus Q and this be minus Q. So now what I'm going to do, I'm going to transfer an infinitesimally small amount of charge from the positively charged plate to the negatively charged plate. By the word infinitesimal, I mean a charge dq from positive to negative. So that is, I'm going to increase the charge from q to q plus dq. So now we are going to calculate the work done to increase this charge. The work done to increase this charge from q to dq. The work done is given by potential energy q is equal to qv. So now we are not going to transfer the entire charge plus q. We are going to just transfer an infinitesimal charge. So write the same equation in differential form. Du is equal to v. So now on integrating this equation, you get integral of du is equal to integral of v dq. So for potential, we have to substitute the equation v is equal to q by c. So this equation we got from the previous equation for capacitance. C is equal to q by v. And when you rearrange this equation, you will get this. So integral of du is equal to u equal to w. That is given by integral of q by c dq. So here capacitance is a constant. So we'll take it out of the integral of q dq. So on integrating this equation, we get 1 by c into q square by 2. So the final equation is q square by 2c. U is equal to q square by 2c. So for the value of charge, you can substitute q is equal to cv. So you will get c square v square by 2c, that is half c v square. So this is the equation for potential energy that is stored in a capacitor. Potential energy of a capacitor. I hope you understood the topics. If you have any doubt, please let us know. Thank you.